So today we'll be making the circuit diagram of a half-wave rectifier circuit, as I said in the previous lab, and I had drawn the circuit diagram of the same. So here I'll be recording the video so that it becomes easy for you to do it at your own place on your laptops or on your mobile phones. Or even if you're not able to do it, you can just view this video and get an idea of how the circuit works and what is the output and the input waveform of the circuit. Fine. So we'll get started. I've already made a project like a rectifier project in my after logging in onto the Easy EDA editor mode. Remember, for the circuit simulation, we have to choose the simulation mode and not the standard mode. So we'll get started. Like here, we'll choose a voltage source. First, we need to have, as per the diagram which we have drawn, we need to have a voltage source. We need to have a diode. So from the library, which is on the left hand side, we can choose for any of the component which is of our choice, or else we can go directly into the library and type the search items there, and we can just check it from there. So after selecting from here, we simply need to drag it here and then right click it. So it is here. We need to have a load resistor. Load resistor is here somewhere. Yeah, this is the load resistor. It's a 1 kilo ohm load resistor. Drag it, place it, and then right click. And for rotating it vertically, simply press the R key of your keyboard. So it is like this. And there's no other component required for completing the circuit other than now the connecting wires. So the connecting wires, as I told you in the previous video, we'll be taking the connecting wires from the wiring tools. So here we select the wiring tool and we're going to join the positive end of the AC supply to the diode P side for forward biasing the diode, or for the positive rectification here, right? So this is connected. Again, take the wiring tool, connect this end of the diode to this end of the resistor. It is done. Again, taking the wiring tool, connecting this end with this end of the resistor, another end. Now this terminal of the resistor and the negative terminal of the sine wave needs to be grounded. So from the wiring tools, here is the symbol for the ground. So we pick up the ground from there and we place it here. Okay, right click. So the circuit is complete. Now since we want to measure the output voltage can be measured across R1, that is the load resistor. If you want to rename it as RL, simply double click on it and write it as, replace it by any other name which is suitable to it. For your convenience, I have renamed it as RL, that is the load resistance. And now we want to measure the voltage across the load resistance. That will be obviously our output voltage. So we'll take the voltage probe which is here and we place the voltage probe here. So wherever, at whatever terminal we want to measure the voltage, we simply need to select the voltage probe and place it onto that very terminal. So it is here. We can rename this voltage probe 1 as V out, voltage out, that is the output voltage. So this is done. And now let us change some of the attributes of the input voltage. So this is V1. Double click onto it. On the right hand side, we'll get a window where we can change its frequency, we can change its delay, we can change the theta and many other things about it. So amplitude, we'll keep it as 10 volts. So we keep 10. Frequency 50 hertz is okay. Delay, we'll keep it as 0 or no delay. Then theta, we'll also, these are other attributes. Theta and phi, we'll all keep it as 0 and nothing. So you can see now it has changed. It's sine 0, 10 and 50. So 0 stands for the DC offset, 10 is the amplitude of the sine wave, and 50 is the frequency. So this is done. Now after making this circuit, we simply have to go to File and Save. So the circuit will be saved. Okay, since my internet connection is not on, I'll try to connect and then my circuit will be saved, because these are all the online simulations. So for these simulations, we need to connect to the server. And so now my internet connection is up, and okay, so let me go to file and let me go to save. So it's showing connecting to server. So it will connect to the server and I'll get a message that the circuit has been saved successfully. Okay, I've got the message that it has been saved now. Now, when I go to the simulation, before running the simulation, I need to go to the simulation settings. Simulation settings, we'll get many, headings under this run your simulation. That is the transient, where time is varied, AC analysis, DC sweep, DC transfer. And here, but transient is simply like you select the time for which your simulation will be running. So here, I have selected 2. So that is 2 seconds. Okay. So I keep it as run. Okay. It will show me that stop time, start time should be there. I'll say okay. Fine. And then I cancel it. And here you can see it is dot trans 2. That means it will run the transient simulation for 2 seconds. So that's all what I need to do. And now I'll go to simulation and run your simulation. So I'm running my simulation. And now I'm getting the output waveform. You can see the blue one, it is written as voltage at VOL out. VOL out is simply your the voltage which is measured by the voltage probe placed across RL. So this is the output voltage. So we can see it here. And as per the orientation of the diode, it should be positive rectification. So here we can see that only the positive half cycle is there, negative has been rectified, and negative has been cut off, and we are getting only the alternate half cycles of the positive half cycle of the sine wave. So this completes our positive half wave rectification. Right. And one more thing, if you want to see that, you want to see the input waveform as well as the output waveform. Input waveform, remember that this input waveform appears across the diode. So let's take a voltage probe, place it here, it's placed, and let's rename it as voltage in, VOL in. So whatever probe variables we are selecting into the circuit, those will appear into the output window. So it's like that. So we have made these changes into the circuit. Go to file, go to save, and then go to the simulation and run your simulation. So you will see here now you have two waveforms now, blue and orange. So the blue one is for the vol in, that means voltage input, and VOL is for the voltage out. Let us see what changes have been made, whether the rectification has occurred or not. So you can yourself see input voltage waveform is blue, which is ranging from positive to the negative value, positive to the negative value. Peak to peak amplitude is 10 plus 10, that is 20 volts. And the output voltage waveform, which is this orange one, is simply only the half cycles. Now, if we want to separate the two waveforms, that is the input and the output waveform, we simply need to go here, which is the waveform coding, and here we'll get name VOL in belongs to pane 1, VOL out belongs to pane 2. So it will separate the waveforms into the two separate graphs or two separate plots, and we apply it, and you can see we're getting now, if you want to see the zoomed version, we can select it and see it like this. So see, this is the input voltage waveform with the positive half cycle and the negative half cycle, and correspondingly you have the output voltage waveform having only the positive half cycles. So this is the positive half wave rectification. And if we want to go for the negative rectification, we simply select it, do rotation R and R. So this is the now we are placing the diode into the reverse bias position, and we go to file, we go to save, we go to simulation and run your simulation. It will give us a waveform which will be the now negative rectification. Okay, now you can see that VOL out is all onto the negative side, that is below 0 volt. So this is the negative rectification. Take a zoomed out version of it. You can see blue one is the input voltage, that is plus half cycle, minus half cycle, and then at the output you will see you'll have only the negative half cycles. The positive has been clipped off and there's only the negative voltage waveform. So that is the half wave rectifier, that is positive rectification and the negative rectification. I hope you'll be able to do it at your own places.